Yeah. Yeah. Yeah.
Do we have a number?
8 inches.
27 feet and 8 inches.
Alright. 30-foot mark.
30 feet right there.
You know. Alright. I think this is good.
Yeah.
Wow, it's very nice.
Speedometer cam. Hitting the first cone now. And done. So this is how the problem can be modeled. Here's Landis, and here's the road that the car is traveling on, along with the start position of the car and the end position of the car, which is the span of 60 feet. So you can see the initial position from the car to Landis is 27.8 feet, and this is the distance the car traveled at 11 miles per hour. Or you can convert that using with the conversion factor 1.466 to get into feet per second, just because everything else is in feet. And since this angle between where the car initially started, where the car initially started in Landis and the car traveling down the road is perpendicular, we can frame this problem using the Pythagorean theorem: x squared plus y squared equals z squared. And that's how we're going to solve this related rate problem. So you can start off by plugging in the x value, 27.8 squared plus 2y dy, using implicit differentiation. You got that, and it equals 2z dz, which is going to also, once you put differentiate it in terms of, well, with regard to dt, you're going to eliminate this since it's a constant and it's not changing, and there's no rate at which it's traveling at. So you're going to come down to 2y dy over dt equals 2z dz dt. Then you can start plugging in values. So y is 60 feet. 16.133 is what we got feet per second. That's the rate at what the car is traveling at in feet per second. Equals 2. And now see, this is what we would call z. But there's no value given for that in the initial problem. However, you can go back to the Pythagorean theorem and find out what z is equal to at the instant when the car is 60 feet away, 60 feet down the road. So simply you would just plug in the values into the Pythagorean theorem: 27.8 squared plus 60 squared equals z squared. And it would come to z equals 66.127. And that's the value you're going to use for z. And now it only comes down to solving for z, since you're trying to find the distance, the rate at which the distance between the car and Landis increases. So yeah, just put all of the numbers on one side, and you'll come up with the answer of 14.638 feet per second.